An airline promotion to business travelers is based on the assumption that 2/3 of business travelers use a laptop computer on overnight business trips. An American Express survey found 355 of 546 business travelers use a laptop computer on overnight business trips. Test the assumption with alpha equal to 0.05. In this case, the claim is that the percentage is 2/3, or I'm going to write that as a decimal, 0.667. So the claim is that it's 2/3, and we're testing to see if that claim is true. So it's going to be a two-tailed test. The alternative is that the percentage is something different than 2/3. So my first step of a hypothesis test, the sample size here is 546, and the percentage is around 66-67%. So we satisfy the conditions for a normal distribution. We'll assume the population percentage is 0.667 and calculate a standard error. I'll again be using the 0.667. And I get 0.0202. The population percentage is assumed to be 0.667. The sample proportion or percentage turns out to be, that's 355 over 546, is 0.65. So actually that may be some evidence to show that the percentage is actually a little lower than what's claimed at 65%. But is that strong enough evidence to reject the null and prove that the 2/3 is wrong? We'll see. Sampling distribution, we've got that. The level of significance is 0.05. So we're going to split alpha here. That'll be a 0.025 on the upper and lower ends, which gives us z-scores of 1.96 and negative 1.96. Step 3. Write a rejection rule. Reject h sub 0 if our z-value is less than negative 1.96 or our z-value is greater than 1.96. And our test statistic, we will take the 0.65 sample percentage, subtract the percentage we're testing against, and divide by the standard deviation or standard error since we're sampling, and end up with a negative 0.84 z-value. So step 5, do not reject h sub 0. Not enough evidence. Not enough evidence to prove that the null is wrong. So basically it's inconclusive. There's not enough evidence to show the null is wrong. Now look at the let's look at the p-value here. The negative 0.84 is about, that z-value is to the left of center a little bit. So my 0.65 is to the left of the 0.667, but it is not far enough to the left to get the rejection. What we would be looking for as a p-value is to look up the negative 0.84. So we go to the normal table and down to row negative 0.8 and over to column 0.04. And so the area in the lower tail is 0.2005. But remember, this is a two-tailed test, so I'm going to multiply that by 2. And get 0.401. And 0.401 is greater than 0.05. So do not reject. Notice in this problem that I didn't have to subtract the 0.2005 from 1 because I'm already looking at the lower end there, and the table in the book always reads to the right as far as matching a z-value to the probability, the area under the curve. So I didn't need to subtract 1 there. But at any rate, that negative 0.84 is just indicates that 0.65 is too close to the 0.667 and not far enough away that we can confidently reject the null hypothesis and be within that 5% chance of making a type 1 error.